Hello guys, welcome back to my channel. So the question is, it is a like very basic question. I need to find the cycle in undirected graph. Okay, so number of vertices is V and E is edges, and we have been provided with adjacency list, and I need to find the cycle if there is a cycle in my undirected graph or not. Okay, so let's try to understand. I'm taking this very first sample test case and try to figure out what should be the approach in need to finding the solution for this part. And I'm going to teach you both ways, BFS as well as DFS. First, I will teach you the BFS, how to come to the approach for BFS. Then I'll go to DFS. So yeah, suppose this is my graph. Okay, 2, 4, and 5. Okay, okay, the same problem. For the BFS, I'll go for very first node and I will store this node in the queue. In the queue, I'm taking two things. First, I'm taking node, and then second, I'm taking its parent. Okay, first I'm taking what? Node, and then I'm taking what? Parent. Good. So what will you guys tell me? What will be the node? Node is 1. What will the parent? Parent will be -1. Okay. Then I'll come to this, and again before storing before inserting any node in the queue, I will mark it as visited because I have visited that node. That's why I will mark as visited. So now I can, comes to the 3, and I will store 3. And what will the parent will be 1, and I will mark it as visited. Then I'll come to its children. What is children? Children is 3 a 2. Children is 2. Then I'll store 2. And what will the parent? Yeah, parent will be 3. What is the children for 3? Children for 3 is 2 and 5, right? So I will store 5 also. And parent is, of course, 3. Okay, before coming to the next, since I have pop out this node from parent from queue, I'm the very first node, very first pair in the queue is 2 and 3, right? 2 and then 3, right? So I'll come for 2 and 3. I will pop the 2 and 3 from the queue, and I will try to find the children for 2, right? So children for 2 is 3 and 4. But why I'm not taking 3? Because 3 is parent. So I'll not take its parent, right? So I'll take 4 here, right? So I'll take 4, and what is this parent? Parent is 2. Okay, and I'll mark it as visited. Now what is the children for 5 and 3? Since I have done with this pair, I'll come to this pair. So 5 children for 5. Children for 5 is I'll first mark it as a pop out. And children for 5 is 3 and 4. Why I'm not taking 3? Because 3 is eh, of course 3 is parent, right? So I'll not take parent children. I'll not take children which are parent, right? So that's why I'm not taking three. No, I will take four. But before I'm taking four, I see there we have marked it as visited. So that's where I come to know that there is cycle, and I will return true, right? From here, I got to know from 5 3 pair in the queue that there is cycle because the children of fifth node is being marked as visited. So that means there is cycle, right? Uh, Let me quickly write the code, and then you will definitely get just what I'm trying to say. Okay, first thing I'll do, I will take visited vector in 0. I will take bool answer as a false. Why? Because answer will be storing whether there is cycle or not. Initially there is false because initially I'm assuming there is no cycle, but my function, which is BFS function, will give me actual answer whether is this cycle or not. I will start with SRC, the node from where I'm starting with, and then I will take adjacent list. I will copy from here. Okay, I need to quickly define Q. And Q, what I'm storing? I'm storing what? In Q, I'm storing two things, node and pair. So that's why I have taken two integer. So very first node will be SRC, and then I'm assuming its parent will be minus one because I'm starting with this very first node. That's why I will run this loop until I'm out of the queue, like there's queue is empty. Then I will take quickly queue dot front. I will pop out this front item from the queue, and I will also mark it as visited. Now in this loop, I'm trying to find the children for I'm taking loop and I will be taking each and every children into consideration for my this node, IT dot first node. So before considering, I need to check whether it is not parent and not been visited. So I'll check first if temp is not equal to my parent, and parent is what? Parent is first, and I'll quickly check if it has not been visited, right? If it is so, then I will push temp and its parent. And if I'm getting false from here, that means I need to check whether it is been visited. But parent is also visited, so I have to check the node is not been parent and it is visited. right? So I need to check if this temp is visited, and if it is so, then it should not be parent. Then I will check temp is not equal to its parent. If it is so, then I will return, not return, I will store true and break, because I got the loop, right? What I'm trying to say that, just a minute.
What I'm trying to say is that why I have written this else condition, because this is making my if condition is making false. So why it's making false? Either this is false or this is false. That means I am coming to a node which is been marked as visited, or I am coming to a node which is parent. If it is parent, then don't have to do anything with that. But if it is marked as visited and it is not been parent, then it should be a cyclic. It should be a cycle, right? Because I'm coming to a node which is being marked as visited and it is not parent, then there is a cycle. That's why I'm marking answer as true and returning breaking out of the loop. After coming from this for loop, I need to check if answer is true. If answer is true, then I will break from this while loop as well, right? Right. Okay. Now, now tell me whether this function will run all my test case. No, it will not. I have not told you anything about this test case. See, this is also a this is also a tree. This is also a tree. Together we can say it is a graph. Go to the basic definition of the graph, you will come to know. What I'm trying to say is this is a tree. Fine. This is also a tree, but together it is making a graph, and that's why I need to find. And I need to check for each and every node. Okay. Okay.
So for both, this is tree, and taking both, we can say it is graph. Fine. Go to the basic definition of the graph. You will get it. So if this is the case, that means I have to take a loop, and I have to traverse for each and every node, and I will run this function for each and every node. Before running this function for each and every node, I will first check if that node is not been visited. If it has not been visited, so I'll try to run this function for that node as well, because there can be the case that this node can have multiple children. Okay, so I don't want to waste this graph, this tree. So I'll quickly write. Oh, see, as I told you, I'll take loop. Okay, first of all, I will check. Okay, if my node is not been visited, fine. If it is not been visited, then what I'll do? I will run BFS. BFS I am taking ith node and adjacent vector. Okay, no, I have to check one more condition. What? Suppose I have gone to zeroth node, and again I'm going for the like index number 2 or index number 3. But in the zeroth index, I get that there is cycle due to zeroth index. I mean zeroth node. So I will not waste my time in going to other nodes. From here itself, I will return true if my answer is true. Okay. So what I'm going to return answer. You got it now? Why I'm taking this condition? Uh, See, the why condition I'm taking here. Suppose, let's say this is the graph. Fine. Due to zeroth index, I am taking starting from the zeroth index. So due to zeroth index, I got to know that there is cycle. As you can see, there is cycle. But again, if suppose I'm taking fifth node, here is not fifth node, but imaginary there will be. Imagine there is one other node that is fifth node. And I don't want to waste my time since I got my cycle. I don't want to waste my time in checking other nodes. So I'll take a if condition and I'll check if I got my answer. That is, answer is equal to true. If answer is equal to true, then I will break. I will come out from this loop. I don't want to waste my time in checking other nodes. So and I will return answer from here itself. That's the basic thing. Now I'm going to compile and run. Let's check whether it will run or not. There is a compilation error. What is this? What is an? Okay, I have to take an. Let's take an. Now you guys tell me what should be the n. Take a pause. See, and I'm taking global value, no? That's why I have to take maximum value of n. So what is maximum? In constant itself is given. It will be 10 power minus 10 power 5. That's how. That's what I'll take. Let's see. Yeah, it's running. Let's submit the code. Yeah, it is passed. The problem has been solved and it passes all my test cases. But this is the BFS approach. I need to also teach you the DFS approach as well. Now you guys tell me what should be my DFS approach. See, in DFS, I don't have to uh, do like major changes. For let's say, let's have another board. See, this is my tree. This is tree. Okay. Mm, okay. This is the sample test case one. For DFS approach, again, I'm starting with zeroth node and I will go for its children. One, two, three, and four. For children part, what I'll do, see, I will come from 0 to 2, and I will go for children for the tooth index. And before going for the next children, I will need to find if it has been visited or not. It's been visited, that I'll mark visited. It is also visited, I'll mark visited. And I will go to 1. From 2, I will go to 1 and I will mark as visited. From 2, I will go to 4 and I will mark as visited. And again, before that, before coming to 4, I'm going to 1 now. From 2, I'm going to 1. So I'll mark as visited. Fine. From 1, I am going to 3 and I will mark as visited. And from 3, I will check its children. See, when I'm checking for children, 1 is also children for 3. But I'm not taking 1 because I will take a condition here that children should not be equal to parent. That is the basic thing I have taught you. That's why I'm not teaching you again. So for 3, the children is 4 and 1. I'm not taking 1 because it is parent. So 4 is parent. I will mark it visited. For 4, the children is 3 and 2. I'm not taking 3 because it is parent. And when I'm taking 2 as a children for 4, I see that there is marked as visited. So this is returning true because there is cycle. The basic thing, and I don't need to change much line in the code. Uh, First of all, I have to take DFS. Here I'm taking source and I will take parent. Fine. Visited I have taken already. True or false I have taken already. That's not issue. And in this case, node, I don't have to change much. I will quickly write the code. Visited 1, force and 2. Sorry. I will check first before visiting its children whether it is not been marked as visited. It should not mark. If it is not marked as children, then I will cover for that part as well. What should be the parent? Parent should be SRC and adjacent. I need to return bool here. If DFS is returning true, then I will return true from here as well. Okay, and if it is marked as visited, so again I will check whether it is not equal to parent. Fine. If temp is not equal to parent and it is being marked as visited, that means what? I got cycle. Okay. Okay. If I'm coming out of this loop, that means I don't get any cycle and I will return false. Okay. For this part, and the same thing I'm taking. If answer is equal to answer we got true, then I will coming out of the loop. And if I'm checking it is visited, then I'll take DFS int I ith index and parent will be -1 adjacent. Fine. If DFS is returning true, then I'll return true from here itself. Otherwise, false. I don't need to take answer because I'm not storing any answer from here. Let's run this code quickly and check whether I need to make any other changes. No, it's not. So this passes all my test cases, as I can see. Yeah, so it's passed all my test cases. I hope you guys like my video. If you guys liked, then please like and share and subscribe and see you in the next time. Thank you.